Stoner's Garage. Today we want to talk about Pascal's principle. And Pascal's principle says that to lift something up, you need two cylinders or two pressures. So I have a floor jack here today. So if you come over here and look at the floor jack, there's two cylinders on this floor jack. Here's the first one, a small one. And when I pump it, it goes up and down. It's pushing fluid into a much larger cylinder, which we'll show on the other side here. And here's the much larger cylinder. So the pressure in the little cylinder has to equal the pressure in the big cylinder, which makes the jack go up. All right. So today we're going to try to actually jack up the 66 Mustang with the floor jack, 3-ton floor jack. So you find a good place under the car. I'm on what they call the pumpkin, or the center of the differential on the rear end. And it's not taking me very much force. Remember mechanical advantage, we talked about that with simple machines. I'm not pressing very hard, but I can lift this car up pretty easily, which probably weighs about 4,500 pounds. Next rule was never crawl underneath it without putting something under to support it. So if you look beside the car, I got a couple jack stands. I'm going to put one of those on each side. All right, we'll explain a little bit more on the video, or after the video, on Pascal's principle. Pressure in one equals pressure in the second. Thanks for watching.
Pascal's principle says that the pressure applied to a fluid is transmitted unchanged throughout the fluid. In the pictures, if you squeeze a balloon on one end, when it's blown up, you push the balloon out to the other end, in this case, around your thumb, on either side of your thumb, with the same amount of pressure. And the same is true with toothpaste. If you squeeze one end of the toothpaste tube, you'll push that fluid, the toothpaste, out the other end with the same amount of pressure. The example we used in the garage was the floor jack. And the floor jack is used to lift something up very heavy that you couldn't lift without the floor jack. And this particular floor jack, and most of them, have two cylinders, a very small cylinder, which I have in yellow, and a large cylinder, which I have in magenta. The small cylinder is located underneath the handle, and it is a really, really long handle, which gives you leverage, mechanical advantage. And this is definitely a first-class lever, by the way, because you have your effort to the left, you have your fulcrum, which is where the small cylinder is, and the resistance is where the car would go on the right. So it's a first-class lever. As you pump that very long handle, you are putting pressure in that small cylinder. You're moving the fluid. That fluid in turn will flow over to the larger cylinder, and the pressures will be equal, and you'll be able to lift the car up with that jack. There's no way that if we switch those two cylinders around that you could pump that jack handle and pump the pressure that you can in the little cylinder into the larger one if the two cylinders were flip-flopped. That's why we have the small cylinder. It's a lot easier for us to put the force into that small area, which in turn then will give us the same pressure. So let's go a little deeper here. So we have the two cylinders. Pascal said that the pressure equals the force divided by area. So F1 over A1 equals F2 over A2. Pressure in the first one, small cylinder, equals pressure in the second. What if we put some numbers with this? What if we say that the small cylinder, when you have to jack the handle up and down, you put in a force of 10 newtons. In the area of that cylinder, let's say it's 0.25 meters squared. So you're jacking that up, you're taking the handle up and down, which is going to cause a pressure in the small cylinder. The magenta cylinder appears to be about 4 to 5, let's say 5 times larger than the yellow cylinder. So I took all my numbers, and instead of having 10 newtons of force, I am now putting in 50 newtons of force. We do the same thing with the denominator. If we take 5 times 0.25, gives us an area of 1.25 for the magenta cylinder. So on the left we have 10 newtons divided by 0.25 equals 40 pascals. And on the right we have 50 newtons divided by 1.25, which equals 40 pascals. So left side pressure 1 is 40, right side is 40. Jack will lift up and down, lift the car.